Well, thank you so much for having me here. This is a super exciting. All of BBQS is super exciting, and I just feel like it's a privilege to be a part of it. So the project that I'm going to tell you about, the R61 that my team and I have put together, is this awesome acronym called CAMERA, the Context-Aware Multimodal Ecological Research and Assessment Platform, the CAMERA platform. This is the project with myself at Columbia University, along with Brett Youngerman, a neurosurgeon at the medical center, as well as with Jorge Ortiz, a computer scientist at Rutgers University, and Alec Widge at the University of Minnesota. The core of CAMERA is about, was fundamentally, we came up with the idea for CAMERA from a scientific question about the neural basis of memory and anxiety. And we were brainstorming about how to help people with memory and anxiety disorders using brain stimulation. If you have people have memory and anxiety disorders, and if you have a methodology for applying brain stimulation to help those people, then the question is, when should you apply brain stimulation to help people who, to help people's memory and their anxiety improve? We didn't have a lot of information on this problem because we don't have a lot of data on what memory and anxiety look like in the human brain and in the human body overall for long periods of time. And CAMERA is a framework for collecting more data on how the brain, on how physiological and neural processes relate to memory and anxiety. One piece of preliminary data that we had is a signal called the hippocampal theta oscillation, which you can see here, is related to memory and anxiety. Theta oscillations show up at about anywhere between 3 and 8 hertz in the human hippocampus. They're also been seen a lot in rats, and we have reason to think from human and rat studies that theta oscillations are related to memory and anxiety. And we thought that we could use theta oscillations as a trigger to help to develop brain stimulation protocols to help people with memory disorders and anxiety disorders. But wouldn't it be great if we could also help people with more sophisticated other kinds of biomarkers beyond these intracranial brain recordings? And CAMERA is a large-scale framework for collecting a large number of signals related to memory and anxiety for large periods of time in the human brain. So CAMERA is a big data project to predict memory and anxiety using neural and non-neural biomarkers of human memory. The focus of CAMERA is recording these signals in patients who are undergoing treatment for drug-resistant epilepsies and who are sitting in a hospital room, which we can instrument with a lot of different brain recording signals. As you can see here, here's a past patient who's undergoing treatment for epilepsy, monitoring for epilepsy, recording all of these signals for long periods of time, recording them in parallel, and using machine learning to measure neural and physiological signals to predict when to apply brain stimulation to help people who have memory and anxiety disorders. The most exciting thing about CAMERA is that we started with some preliminary data, as I mentioned, about using intracranial brain recordings to related to theta oscillations, as I mentioned, and we had reason to think from our earlier work that intracranial brain signals were related to memory, help us predict memory and anxiety states. But CAMERA adds on to that in what I think is just about the most ambitious framework that I can think of for adding different kinds of methodologies and recording them in parallel with intracranial and scalp EEG brain signals to identify how the entire body changes when you're in a high memory or a high anxiety state. So CAMERA is all about instrumenting the epilepsy monitoring unit with a large number of different sensors. One of the sensors is a smart wristwatch that measures cardiac activity, electrodermal activity, and skin temperature on a wristwatch, like as you can see here. We are also measuring subjects' behavior using their smartphone. People who are undergoing treatment for epilepsy have their smartphone here, and they're sitting there for a couple of weeks, and like any of us, they're going to be texting their friends and emailing. And we have special software which will anonymously and ethically log linguistic features from their smartphone behaviors as time is going on during their stint in the epilepsy monitoring unit. We are using audiovisual tracking, two or more cameras to measure their video to record video of their movements, to posture tracking with machine learning, and also to measure auditory processing, to measure their voice and their spoken words and things like that. And we are synchronizing all of these different sensors, neurophysiological, physiological, video, smartphone, all through a software package called BCI 2000 to have a single stream that's all synchronized with high resolution to to give us a single signal stream, all synchronized together. Once we have this high resolution signal, we are then synchronizing all those signals with something we call an EMA. An EMA here is a special, so if you want to study memory and anxiety in long periods of time, one challenge is you need to ask subjects, what is your memory state and what is your anxiety state? And we have developed an iPad-based memory and anxiety assessment paradigm called an EMA, where we have an iPad that patients can use at their bedside that tests them on their memory. As you can see here, they do a spatial object location memory task called treasure hunt. And we also have them answer questions about their anxiety state as time goes on, and we have them do this about 5 or 6 or 7 times a day, which gives us longitudinal measurements of their memory and anxiety state, which are synchronized with their physiological and non-physiological measurements. So this is really like the most comprehensive measurement that I'm aware of for getting detailed information on memory and anxiety for long periods of time, synchronized to physiological measurements that I know of. So this is what the overall framework looks like. We're collecting all of these different data sets together, physiological data, multiple cameras, audio, blinks, the EMA, and we're synchronizing it all together using this real-time framework. 2 minutes? Okay.
Yes.
So this is the big picture framework that we have here. And then we will be processing this whole framework, all this rich data set using deep learning. And one of my co-investigators, Jorge Ortiz, is on the call. He's a machine learning expert from Rutgers. And Jorge is developing frameworks for studying, for predicting when subjects are in high and low memory states and anxiety states, using the physiological biomarkers that we're measuring in order to predict when subjects need brain stimulation to help their memory, or when we may, at the very least, we're not sure if their memory state, and then we need to give them a memory test to see if they're in a good position or a bad position overall. That's what we call the uncertainty net, to see if we can use, if we need to run another EMA to see how well they're doing at that moment. And then finally, using this whole framework, we're applying closed loop brain stimulation also at the times when the framework says we need to apply stimulation to help those people. So we're testing whether all of these signals that we're measuring are causal, and that's what the closed loop stimulation is, both a causal test of the whole framework as well as trying to develop better phase-locked methods for applying stimulation to help people with memory disorders. And then finally, in order to test whether in order to build onto the causal tests, we're not only measuring whether the closed-loop stimulation is helping their memory state, but also whether we are helping the biomarkers, such as those theta oscillations, to really see if we are closing the loop fully to change the biomarkers related to memory encoding more broadly with the EMA-triggered stimulation. So I will wrap up there. Here, this is a list of me and my co-Is here: Brett Youngerman, Jorge Ortiz, Alec Widge, and my name is Josh Jacobs. Thanks again for the opportunity, and I would love to take your questions.